The Hong Kong Museum of Medical Sciences Society is proud to present the 3D printed copper acupuncture human model, or 3D Acu-Man. The first well-known historical acupuncture model was created in Song Dynasty in the year 1027, 1,000 years ago, by Wang Weiyi for the Imperial Medical School. Through his wise knowledge of Chinese medicine, the human-sized statue through metal bronze craftsmanship standardized acupuncture for teaching, so that everyone could follow one-to-one scale to learn acupuncture with no error. Now, after 1,000 years, for our Museum of Medical Sciences, we constructed the 3D Acu-Man model. Thanks to many acupuncture experts and technological professionals, the technical feats were overcome, including precise conversion of acupuncture points into 3D body space and achieving 3D printing of a one-to-one scale human-sized statue engraved with acupuncture data, hoping that through interactive experiences, visitors can appreciate the wealth of acupuncture and its different learning levels. And if a click in a physical model can demonstrate a lot, we realized the dream. Acupuncture is a great treasure.
The core technologies of 3D Acu-Man are: 1. Using scanned digital data for reconstruction of the Aquaman digital model. 2. Metal 3D printing using FDM-based 3D printer. 3. Multimedia augmented reality art tracking system for acupuncture teaching and training. Metal 3D printing of an over 6 feet human model was a challenge. Machine stability, temperature, humidity have to be controlled accurately. After printing, the model required grinding, finishing, and polishing to get a metal shining surface. 2 types of augmented reality art tracking systems are commonly used today, optical and magnetic types. The tracking distance, accuracy, detector size, and power consumptions are different. The tracking system we used is infrared-based type and able to cover the volume of a full-size human at an accuracy of ±5 mm. It can also be scaled up to multiple users' applications. Today, augmented reality art tracking systems have been used in games, sports, dancings, and trainings. We have applied augmented reality art tracking technology in our traditional Chinese medicine acupuncture teaching and training application. Some game engines have been adopted in military and medical trainings because of their highly realistic computer graphics, speed and adaptability. You can see the high-fidelity rendering of the screen here. The game engines even have the functions to simulate the gravity, wind, lightings, and other physical properties. This is an example of applying a game engine in our tracking software. We can import the human model with the acupuncture points in the engine. Inside this engine, there is a library used for connecting the tracking devices. The design setup of 3D Acu-Man including the model, a large LCD monitor, tracking system, and a wand. 2 infrared receivers were installed in the 3D printed human model and the wand as shown. This is the mathematics of the tracking software. A number of emitters located at the floor. The emitters emit infrared light to the infrared receivers on the model and the wand. The receivers after received the infrared lights from the emitters from different distances and angles in 3D space. They can send the information to the computer. The receiver in the human model can synchronize 3D location of the 3D printed model with the digital model in the computer after calibrated. The receiver in the wand provides a tool for user to find the acupuncture points. This equation represented the ordinations, size, of a tracking point. Since there were 12 emitters, a mean value of the tracking point was computed. During the tracking, at least 3 emitters should be found by the receiver to get an acceptable result. If the tracking point of the wand was close to an acupuncture point, a collision was detected. It meant that the acupuncture point was found. The tracking system required a simple calibration before production. A 2-year calibration technique has been adopted as daily calibration routine procedure. This is a photo of the final setup of the 3D Acu-Man. The 120 kg model was installed on a mobile platform which could be moved and relocated within the museum building. The 3D Aquaman demonstration could be started as following. When the user entered into the program, he or she could select basic mode or advanced mode of the acupuncture training program. In basic mode, the user was requested to find an acupuncture point from the model. Then, he or she could pick up their wand to find the requested acupuncture point. Once user found it, the computer would return a well-done voice message. Eventually, the user could learn about the various locations of the human acupuncture point. In advanced mode, the user was requested to find a few acupuncture points from the model. Most of the time, these acupuncture points were all related to a sickness. In this example, 4 acupuncture points were requested to find. Once user found them, the computer would return a well-done voice message as well. Through this game, users could learn about the acupuncture points relating to the sickness. It is educational and full of fun to play with 3D Acu-Man model.
The therapeutic practice of acupuncture is now generally widely accepted in the world, even in academic circles. Over the long years, sophisticated theories and ways of use of needles through the body surface at strategic points have been established and standardized. For training, old traditional models as wood, metal, or classic mannequin models with acupuncture points marked are often too rigid and may not be realistic enough. Our highlights are a 1,000 years revival, new challenge of technology for Chinese medicine, an approachable physical model for acupuncture learning, a transformed wealth of knowledge, offering a service for clinical acupuncture learning and experiential interactive learning. Nothing is better than a full human-sized model approachable with close to actual hands-on experience and further enhanced by interactive IT whence a click at the correct acupoint would source out a good information. Our model should in time meet the challenges of future, rather than just knowing the acupuncture points by the surface map. Advanced understanding has further get to the probable sites of acupuncture points inside the body through gauging depths and directions of needling, and can be demonstrated as if by MRI scans. In making our model from computerized tomographic images of a normal human body to 3D reconstruction, then precise conversion of acupuncture points into the 3D body space, till the end product 3D printed copper Acu-Man, we established a template whereby seeking support from further multiple sources for their intelligence will allow further model transformation and enrich the acupuncture knowledge presented. Most can gain satisfaction in the joy of discovery. We are greatly thankful for the support of the workforce and the technological team and the Innovation Technology Commission of Hong Kong. Hopefully, with funding allowed, more technological sophistication and knowledgeable information can be installed in later stages to realize the full model, providing for better educational support for Chinese medicine and even advancing to application clinically.